Professor VijayRaghavan. Sir, basically we want to know from your understanding and simplified as you're so good at doing, how did this pandemic start? Because we learn from that. And how is it spreading, or how do pandemics generally spread? And basically, what can we do to reduce the impact that a pandemic has on our lives?
This is a very important question, and there is a narrative in the public which is, which makes for a good story, that someone went to a wet market in the Hunan market in Wuhan and bought something, a bat or a pangolin, and by maybe touched their nose or face after that, and then the whole thing started. Now, this may well be true as a matter of fact, given that we know that there was one spillover event. But it would be wrong to assume from this that if that event had not happened, there would not have been a pandemic. Pandemics happen because these kinds of events are made more and more likely, or there is a prolonged period during which such interactions occur, and therefore, over time, even though there's an event of very low probability, over a long period of time, such a low probability event happens. So yes, it did move from an animal such as a bat or a pangolin to a human, but it's not just one off event. It is the interactions have been going on for a very long time. And indeed, it looks like bats and humans have cohabited in many ways right through human civilization. Now, the related point is, why do bats have these kinds of viruses in such large numbers? And that was discovered in 2003 by epidemiologists and people who study evolution of these viruses and zoonotic jumps from animals such as bats to humans. In 2003, people explored bat caves and bat markets in China and discovered a huge range of coronaviruses in them. And since then, coronaviruses of this kind have been found in bats all over the world. So this is a very important scientific discovery about this. So the question is, if these bats harbor these viruses, how come they are not affected? And that again has been an area of study, and much new information has come on that over the years. And that's because these flying mammals are powered, use so much energy in flying that they need to downplay the inflammatory response in their immune system so that they can handle the metabolic activity required for flying and not get constantly battered by infection by over-responding to them. And therefore, bats, by this accident, have become an extraordinary experimental laboratory for these viruses, many kinds of coronaviruses, to sit together, exchange genetic material, and make newer kinds of viruses without harming the bats themselves. Now, these kinds of coronaviruses, bats aside, they also cause common colds, which infect our upper respiratory tract. Unlike the severe acute respiratory syndrome, SARS, and the MERS, Middle Eastern Respiratory Syndrome viruses, which infect our lower respiratory tract. Those cause extremely severe fatality, a high fatality rate, but they're not easily transmissible. Common colds are easily transmissible, but they don't have a high fatality. What SARS coronavirus has done in a very insidious manner has merged transmissibility with this fatality, which is very high. And therefore, it is particularly lethal.
That's really fascinating. The combination of high fatality and highly infectious is what this COVID-19 is all about. And what the other thing was mind-blowing, and you explained it so clearly, that bats tend to downplay the system reaction to the infection. The problem with humans, that's the opposite of the problem with us humans, that we over-respond to this virus. And that causes greater illness. Is that right, roughly?
Well, because what happens is that first, when the infection comes in, the immune system, by a variety of ways, by the virus, is suppressed in a very light touch but effective manner. So many people don't respond well. But then as the virus overwhelms the body, the immune system kicks in with a huge number of viruses. And it does so with such non-specific ferocity that it affects both the virus as well as us. And that's the cause of many of the severe problems. Now, how does the virus get in? And that again, the bat has served as an extraordinary laboratory. It has experimented, the virus has experimented to find the perfect fit between lock and key so that some things on the surface of our cells provides the entry point for the virus because it matches perfectly with the tip of the virus's protein. And we know what those virus protein tips are and what those entry points are. Those entry points are those involved in our blood pressure, in our hypertension pathway, and those proteins are expressed in our kidney, our lungs, and many other tissues. But the virus uses it entry from our respiratory tract. So this, again, is an enormous evolutionary process, slow but steady, where the lock and key fit has been done in extraordinary ways.